Hello, hello. Hello, everyone. So my name is Martin, and today I'm here to talk about libraries. So I know we are at Android makers, and most of you are probably app developers, so I want to make a small show of hands first. Who has already shipped a library here? Wow, awesome. That's very cool. So I hope I will be able to give you a few tips for shipping libraries for the next 25 years. So I always get the question, why 25? And the reason is because I started working full-time on libraries 4 years ago. And it was 2020, if my math is good. And in 2020, Java was 25 years old exactly. And felt like Java was a grown-up, right? It was 25 years old, people had a vast amount of time to think about the best practices, what to do, what to expect from a library. And on the other hand, like we had Kotlin that was like maybe 4 or 5 years old, and it was very much a teenager phase, wanted to try everything in life, you know, data classes, extension functions, multi-platform. And it was a bit disorienting. I was like, yeah, I want to try everything. But on the other hand, do people really know how to use all that stuff? So, I don't know, 4 years later, I made a lot of mistakes, which I'm going to share with you today. And I kept the title. Also 25 years, because this is more or less the amount of time I can see myself doing this. So I'm looking forward to meet you all in 25 years again at Android Makers and see what we've accomplished. I'm going to talk about this library here, like use it as an example because this is what I mostly work on. It's called Apollo Kotlin. It's a GraphQL client libraries. The main promise of Apollo Kotlin is that you take a GraphQL query and it generates Kotlin code for you. This is not a talk about GraphQL. I just thought I would introduce it so that if I mention Apollo, you know, well, that's more or less what I do every day. And in 2020, I was like, well, GraphQL client, how hard can it be, right? Just network operation. In 2 years, it's going to be over and can do something else. Well, I'm here now. And so I like to start about naming. Like, I want to say that I'm not the expert about all of that. Like, it's a very vast topic. So a lot of people may have different opinions, but I still want to share mine. And hopefully this is why you are here as well, to hear my opinions. I don't know, we'll see. So I see a lot of people, they want to create a new library, and they call it a very descriptive name. Let's say you want to build a new build system, and you need to parse YAML for some reason. Some people might want to do this. You might name your library Kotlin YAML parser. This is really bad. This is really bad for a couple of reasons. First of all, no one can tell the difference between your library and another Kotlin YAML parser. Like, what makes your library unique? Well, I don't know. Am I going to remember this? Well, probably not. But most importantly, you just lost a very important occasion to tell something about your library. If people come to your GitHub repository, they already know. They're looking for a YAML parser, so they know what they're going to find. If you give it a very basic name, descriptive name, you lose an opportunity to give extra information and tell a story. So I don't know, maybe call it sweet potato. Do you get the link between YAML and sweet potato? No, maybe not. Yeah, sweet potato is a yams. A yams in English is a sweet potato. Anyways. If you're a fan of board games, you can call it Yahtzee. It's, again, just because there is yeah. If you have a dog named Pancakes, this is how I will name my future dog, if I ever have one. Call it Pancake. I don't know. These are not great names. I'm not saying this is like awesome, but this is always better than something that is too descriptive and that people will always forget. Also, try not to be too restrictive in your initial name. Let's say you're building, I don't know, a framework for building UIs on iOS and Android. Do not call it androidx.compose. This is not going to age well. So few recap about naming, and I really insist on naming because I love naming stuff. Do not use boring names, do not use too restrictive names, and instead go wild, go crazy. This is the time to be really crazy about your project. You don't have to add a K to every project, like especially in 25 years. We will have exhausted all the names with a K. So we need to find some new names. And so you can go crazy on the name, but then you need to design. So I'm going to now go through all the different phases of working in your library. So naming it, designing it, coding it, of course, document, publish, and then we will see about evolution. And in terms of design, there is one question that you need to answer really quickly, and I wish we had taken more time to think about this in 2020, is do you want to support Java? So again, all of this I'm saying is in the context of Kotlin, but Kotlin has a wonderful interop story with Java. If you write Kotlin, you can call Java from Kotlin and the other way around. I think this is why we all love Kotlin, at least in 2020. There are some things that are a bit awkward, like extension functions, default parameter values, but you can still manage. There are some things, though, that, well, you can do whatever you want. Good luck finding a Java dev and having them call coroutines API. And same thing for compose. So that's something you need to take into account really early, because this is going to have a huge impact into how your API is going to look like. Other language start with the same word, but not at all similar, JavaScript. We all know Kotlin can target JavaScript, but JavaScript has no thread. Like whether you're on Android or on iOS, you have threads, you can do blocking operations, you can call a very low-level primitive from your OS. In JavaScript, you don't have any of this. So in Apollo, we had something like this. We do network calls, so we took inspiration from the best out there, Ktor and OKHTTP, and we made a wrapper API like this. Simple wrapper. Take a HTTP request, return the response. It's suspend because we put coroutines. And it returns a response with a body, which is an OKIO buffer source, which is Kotlin multi-platform, and awesome. And you can read that body byte after byte and parse the JSON as soon as you read the bytes. So this is super performant. Like you do blocking I/O and you amortize the parsing of the JSON during your network I/O. This works really well. Except if you do this in Kotlin, in JavaScript, sorry, it's going to perform really badly. First of all, because you cannot block your main thread in JavaScript. And second of all, because reading byte by byte, it's going to be very, very slow. So we had a few users really dive deep into this, and the way they solved it is by introducing another async API just for JavaScript. That is a lot faster, but now it means we have two APIs. And again, I wish we had thought that earlier. If you follow a bit the Kotlin ecosystem, you might have heard about KotlinX.io. That is looking right now into introducing an async API, and it's taking a bit of time, and I'm guessing this is somewhat related to this situation. Like JavaScript is fundamentally different. So these were like the two big things. Think about Java, JavaScript. These are the doors that once you open them, it's really hard to go back and close them. And then there's a lot of other small things. First one is don't use data classes. In 2020, I was like, cool, I can write 2 lines of code and have a very fancy data class with copy and everything. Well, I write 2 lines of code. My compilator writes more like 20 lines of code, so it's really, really hard to evolve. Instead, you can use builders. So everyone makes fun of me because I'm a fan of builders, but it's true, they are awesome. You can, with a builder, you can evolve your APIs, and with Kotlin, by the way, this is a model from the Confetti app. That is written by John somewhere. Hey, John. So it's an app that displays conferences, and you have a title and a start time, and so you can build a talk. Like, very simple model. The good thing with builders is that you can turn them into Kotlin very easily by writing a top-level constructor function. So you write your top-level function, and you have something that is a lot more idiomatic, and you keep the Java compatibility. Third thing that is very good with builders is they are tri-state. So you can represent a value, null, or the absence of a value, which is very interesting in GraphQL because GraphQL has stuff like this. If you wanted to update a session in the Confetti app, you would send something like this. If you wanted to unschedule a session, so remove the start time, you would send null instead. And if you wanted to leave the start time untouched, but instead update another data like the title, you would do something like this. If we were using just functions with default parameter values, we would need a lot of optionals because nullable is not enough, right? We need something else. We need a wrapper on top of nullable, so we need optional of nullable, and yeah, it's becoming confusing really fast. And verbose too. With the builders, instead, what you can do is call your builders, and if you don't want to set the start time, you just don't call it here. So it's very easy to represent the third state. So in Apollo Kotlin, we went all the way to default parameter values, and then we reverted everything. I can see some nods in the audience. Back to builders, mainly due to that, and to be honest, it's a lot better. Sealed classes is another example. If you do use sealed classes in Kotlin, it's awesome. You have exhaustive ones and so on. If you have an event interface, for an example, with two kinds of events, maybe you have talks and maybe you have breaks to drink coffee. In your Confetti app, you can display talks and breaks, and you don't have to handle the else case here because you know there's nothing else. But if your library introduces a new event called a keynote, for an example, well, this is not going to be very well perceived by your users because now their old code breaks at compile time, and maybe at runtime if you return keynote. So again, all these things to say that all these small things, these nice features of Kotlin, they are nice to use, but we should all take exercise caution when using them. Extension functions are something else. I love extension functions, but they do have like small issues. If you have a symbol in a class that has the same name as your extension functions, it's going to be shadowed, so your extension function is not going to be called. They also require imports, but on the other hand, like, they are a very nice way to extend your classes and maybe to model your classes. I like to think of Kotlin as something like really immutable, so you have classes like representing data and extension functions representing your code. So the core of the class is just data, yeah, that's what I said. And you can add on top of that extension functions as you want. There's a big question whether you should use tofu or asfoo. Actually, it's not a question. Tofu represents a new thing, so if you mutate the new thing, it doesn't change the old thing, while asfoo returns a view, so if you mutate the new thing, well, you also mutate the old thing. If you don't like those, you can also use foo. Works every time. If you're using extension functions and want Java interop, like this is where Java becomes really important, don't forget to add the annotations. By default, Java will do something like this. If you want to parse a GraphQL document from a string and you want to parse the AST, it's going to take the name of your file here, GraphQL document, prefix with KT, and then use the name of your function. So it's GraphQL document kt.toGraphQL document. That's a lot of GraphQL document. Instead, what you can do is tell to use GraphQL parser as a JVM name. You can also put extension functions in multiple files and have them all in the same Java facade. This is what the multi-file class is here. Happens a bunch if you have Kotlin multi-platform. You have JVM main extension, for an example, and you also have files in common main, so you can merge all of that in Java. And you can also rename your function as well, so this is pretty cool. All of that is, and a lot more, is in the Kotlin API guidelines. There are official guidelines, by the way. Should have put a QR code here. It's on the official Kotlin documentation. There's also a GitHub repo with discussion enabled. So if there's something unclear or you want more guidance, this is the place. There is one thing that I did not mention yet, because it's not in the API guidelines, and it's error handling. So this one, I have feelings about it. I do love Kotlin because it's all type safe, right? And we all do love Kotlin because it's type safe. If not, we would probably do JavaScript. The thing is, error handling, most of the time, it's not very type safe because you just throw something and hope someone catches it. There's a very nice article from Roman Elizarov about Kotlin and exceptions that I have read, like every 6 months I reread it, and I think I understand it now, or at least I hope. What I took away from it is that if you want type safety, you should never throw. So instead, you should use errors with result sealed classes. This way, your caller is forced to handle the different classes. And the 3 first paragraphs are like this, and then it talks about some elephant in the room, and the elephant in the room is not Gradle this time, but it's I/O errors. And so if you want to handle I/O errors every time, it becomes a bit painful, and so I/O errors is the exceptions. So you should never throw unless it's an I/O error. What is an I/O error? It's not 100% clear. Like if you go to the Kotlin stdlib, you have something like this. And this is throwing, right? Here, you take a string, you want to convert it to an integer. If the string is not a valid int, it's going to throw, which is not really an I/O error. So it's like, on the one hand, we have this recommendation, but on the other hand, not really. I do love the or null convention, though, which gives a clear escape room if you want type safety. Also, if you want to use seal result classes, which one should you use? Like Kotlin has this result types that was a bit weird for a long time, but now it's okay to use as a return value. Arrow has a lot of stuff, either and stuff like this. You have more community projects. If you have something that is a bit more domain specific, like an API, you can use something like Sandwich, which models your API in different ways. Arrow also has this Rise DSL, which is a bit closer to what Rust is doing, which is very cool because it's all contextual, happens in the receiver. Or maybe you can just build your own. So what should you do? I don't know. So maybe what you should do is open a discussion on the Kotlin GitHub repository for API guidelines. Something that might work actually is that you do your own thing and you expose wrapper artifacts to interop with something like Arrow, for an example. This way you get the best of both worlds. You still get no dependency, clean API. And if people want to use Arrow, you can still expose everything there. So that was for the API design, which is a lot of what you do as a library developer. Then comes the code. And code is like, well, it's easy, right? Once we have the API, it feels like it's almost the easy part. So I'm going to pass over that and go directly to documentation, because you should document your code, obviously. Documentation happens with Docker. Docker is awesome, and even if you don't publish, you should definitely use it because this is what people will see if they control-click your symbols in the IDE. So definitely do comment all the arguments and return values there. Also, obviously, exceptions if you have any. Two small tips. You can use the versioning plugin so that you host several versions of your API in the same website, allows you to really link to a specific version. And also there is this synth tag that is not present in a lot of documentation. I haven't seen it a lot. That tells you from what version you can really use a symbol. And now, my best part, my favorite one, is publishing. When I first came into that 4 years ago, I was like, what the hell is Maven? You had Maven Central, Maven Build Tool, and well, everything was named Maven, really. And this all comes from this guy here, Maven, the build tool, which is something like Gradle, where it was built by the Apache Foundation, and it's still built by the Apache Foundation. So it's something to build software. So this is like the first thing that came. Maven introduced the Maven repository layout, which is a way to store your files, so you can just store them in a regular directory on your laptop. Like if you publish to Maven local, this is what's happening. Like the M2 here, for an example, it's because this repo layout was introduced with the Maven build tool version 2. So this is why the 2 here. But you can also publish to Maven Central, which is the place that hosts all the software that we use daily. And Maven Central is awesome. Like Maven Central, yeah, I forgot to tell. So this is hosted by Sonotype, so it's kind of a separate company. I'm not sure it's linked to the Apache Foundation, but it's a company that provides a solution for packaging and also supply chain management. And it's really awesome. Like Maven Central is immutable. You can be sure that all the data that you put there is going to stay like forever. It verifies ownership, so you cannot steal someone else's domain, and it enforces a lot of stuff like licenses and signing, and kind of sources in Javadoc. There is one thing with Maven Central, though, is that you have a lot of ways to publish there. Historically, it was all on this website here with a nice UI from the 70s, and in 2021, they decided to update it to, no, not update it actually, just add a new name because vCenter was going down. So a lot of people moved to Maven Central. And so with the added traffic, the original host could not handle everything. So they added a new one, but they kept the old one. That's the thing. So now you had two ways, depending when you created your account to publish. And now, actually 2 months ago, February, 2 months ago, 2024, they're changing everything again, but now it's a nice UI. I don't know if you can see it here, but it looks really good. But the bad thing is that you can still use all the other ones. So if you're looking at documentation online, you're going to find stuff from 10 years ago, maybe, or so. So it's really hard to tell which one to use. And to make matters worse, all the Gradle plugins do not help there. On one hand, you have AGP, Android Gradle plugin, that tells you, hey, I have an API for publishing, so give me the variant you need, and I will create all the publication for you. On the other hand, you have Kotlin multi-platform that says, I can do everything for you. Just apply the Maven publish plugin, and I will create all your publications. And you also have Kotlin, not multi-platform, but Kotlin JVM that says, you know what, I don't know anything about publication, so do it yourself, and I will take the passenger seat. So it's a bit of mess. So hopefully you have tools for that. You have this tool here that is really perfect, except for something. Yes. I can never remember the name. I call it Vanictech Publish plugin, something like this. And it takes care of all of this for you, even creates and closes Maven Central staging repositories and all of that. So with all of that, you're good to publish your library. Now comes for the hard part, because once you have published your library, people are going to use it. That's the goal of it. And if people are going to use it, you don't want to break their software too often. So I'm going to go into a bit of theory about changes. You have source breaking changes on the on the one hand, which are called API changes, which is when your app code does not compile against a newer version of your lib. So this happens at compilation, and on the other hand, you have ABI breaking changes, which happen at runtime when your app does not link when executed against a newer version of your lib. You also have a third version of breaking changes, which are behavior changes, which are basically everything else. Everything you do in a library is a change at the end of the day, so it might break someone's workflow. One could argue that even bug fixes are behavior changes. If you do a typical source breaking change is this, you change a parameter name in Kotlin. Well, this is not going to crash at runtime, but it's going to crash at compile time because name parameters change. Binary breaking is removing a function. Obviously, if you remove a function and someone expects it, it's not going to work well. Typical use case is when you have something like this. So transitive usages, you have one app, two libraries, and they depend on the same libfoo library, but not the same version. So let's say lib_a calls into a certain function of libfoo, and then libfoo gets transitively updated. When you do that at runtime, you will have something like this. No such method exception. I guess you who have had that before? Yeah, everyone. Yeah, happens all the time. There's a solution for that, which is called semver. Semver is when it tells you you can change the minor, you can change the patch, and the consumer will be super happy about it because nothing changed for them. But if you change the major version, anything can change, and this is hell for your users. It doesn't have to be that way, though. You don't have to break people's software. You can also change the package name. So instead of breaking software, just add new software, which is, when you think about it, exactly what GitHub is doing. Like when you add a new commit, you do not delete all the other ones. Also exactly what Maven Central is doing. When you add a new version of your software, you're not removing the old ones. And I think in the community, like not so many repos do it. I think OKHTTP did it, and that's basically it. But I hope we can do more of it. But even if you do this, you still need to educate about the evolution of your library, and for that you have several tools. One of them is deprecated, which is really well. Don't forget to use the replace with, including the imports. Like imports are quite important, and if you're replacing a function, don't forget this parenthesis here, because else it can remove everything. But there are other uses of deprecated. You can use it to direct your users at some other APIs you want. So the Flow coroutine library does that. If you're coming from RxJava, for an example, and you're trying to call subscribe on, well, you will see the symbol in the IDE, but coroutines do not have subscribe on. So they put this nice hint that you should use flow on instead. Another usage of deprecated is to keep binary compatibility. So you can put symbols as hidden so that they are kept in the binary, but no one can call them. Here, this is an example from Kotlin x.datetime, where they had to remove a symbol, but they didn't want to break binary compatibility. I guess because they are not 1.0 yet, they can allow this kind of stuff. So this is for the deprecation. You have the other way, which is requires opt-in, which is really nice. You can declare an annotation as experimental, for an example, and then if people want to use it, they have to opt in your annotation. So it works really nice, except that you end up with stuff like this. So kind of a hot take here. Well, my take, because I think the Compose folks are thinking of something like this and not using them anymore, because if everyone uses your experimental API, how experimental is it, right? You still need to manage the life cycle of it. There's still one interesting use case is that for library authors, which most of us are in this room, not depending on experimental APIs is probably a good idea, but for app developers, everyone is just going to import everything. And for all of that, there's a very nice tool called, very bad name again, I don't know. we have the best tools with the worst names. BCV, I call it BCV for Binary Compatibility Validator, which allows you to track your public API using Kotlin metadata. So it dumps everything to a file that you commit to your repository. If you write something like this, so you have a conference and you can get a talk from a conference, it's going to write a text file, really it's just text, plain dump of your public API. So you have a public constructor and then a function that gets a talk. If you do a change in your Kotlin, it's going also to make a change here. So this is an additive change. That's a nice plus, so we can remember this. If you do a destructive change, which is going to be ABI breaking, there's a minus here. And you can commit that and track your API at each step. The thing is, it doesn't really validate. Well, it's called validator, but it only validates that nothing changed, because it's not able to tell if a change is a breaking change or not. Like if you add a function, like something like this, if you do this, it's going to break your Gradle build in all cases. So it's up to you to go inside each commit and see if the file changed and make sure that it's compatible. The good thing is that it forces you to be aware of that change and update your API file every time. Kind of a hot take here, but I think it supersedes, it's a superset of explicit API. Are you using explicit APIs? No? Oh, good. Explicit API is an option in the Kotlin Gradle plugin where you have to put public in front of every function if you mean it to be public. So it tells you, it forces you to be very explicit about stuff. And I get the intent behind that, but given that you should track your public API with a tool like BCV in all cases, I don't really see the point of having two flavors of Kotlin, where one you have everything public by default and the other one where you have to put public everywhere. So yeah, you can skip explicit API. Well, BCV supports Kotlin native and JS since a couple of weeks, version 0.15.0 beta 1. So if you're doing Kotlin multi-platform, yet another reason to use BCV. It's really cool. Versioning scheme, again, something that I wish we could all agree a bit more on. Like the early days are really easy. Everyone agrees. You have like the pre-release version 0.something, and this is all perfect. This is also the place where you can go wild and be creative. Then you have your major release, 1.0.0, so far so good, and minor version. Then you want to make a new major version. So starting from there, like we do everything with zero-based arrays, but when it comes to libraries, we start with 1. I don't know why. Like, shouldn't we start with 0? But anyways, then you do alpha 2, beta 2, beta 0, beta 1, and so on and so on. release candidates until you ship your major version. And in the whole range of possibilities there, the two extremes are quite easy. On one hand, you have pre-release version. It's like, I'm going crazy, I will break everything, so you shouldn't make too many assumptions about my lib. On the other hand, you have stable versions that are like very well tested. You can use it, it's been battle tested. Use it in production. But the hard part is, this alpha here, like, what does it mean? Does it mean I broke everything yesterday? Or does it mean, well, it's mostly really good, but the API might still change from time to time, so I want to keep my option open. And really, it can mean anything in there. In most cases, though, it means the later one, so that the API is not stable anymore. And what that means is that it's okay to use alphas in production. Actually, it's the best thing you can do for a library. It's use them and make sure that it's working for your project so that they have feedback and can react to anything they need to change before shipping something that's completely stable. So here we are. I hope this was a good overview of all the steps that you needed to write your library. A few takeaways. You can go crazy about names, but not so much about APIs. Like, it's better to use the fancy new stuff for naming rather than try all the new fancy stuff for APIs and language levels. Boring is always better. Boring and consistent is always better. If in doubt, Kotlin stdlib is a very nice source of inspiration. You can always check what they are doing. And the JetBrains API guidelines are also really good, so don't forget to check them. And we also have very nice tools. It's okay to use alphas in production, subliminal message. And since we are all library authors here, it looks like, I want to finish with a last call out, which is we should improve all that stuff, right? A lot of things are really too complicated. So I wish we can do better on the error handling and make versioning conflict a thing of the past so that hopefully when we come back here in 25 years, we have a lot less issues with libraries. With that, thank you very much. And I do think we have time for questions.